Here we go. So the first thing you should do here, we know that rate equals K, NO, and H2. The order which you write these doesn't matter. If you put H2 and then NO, I don't care at all. Okay, next thing to do, I'm going to use the idea we learned yesterday. These are the same. From here to here, I go up 2, right? 2x, or 2 times, I mean. All right, so I look from here to here. How much am I going up? 4. If you can't figure that out, just divide the big by the small. Okay, like if you don't see that's a 4, take this number, divide it by that, and you'll get a 4. Okay. No, I don't go up the list. I go which way the data showed me it changed.
Yeah, but how do you go from 1 to 2? So 1.5.
Because that would just blow every single person's mind. Well, then don't do it that way. If you say you have to and you quartered it, that's fine, but most people don't like fractions.
Okay, so that's just a dumb way to do it. So do 2 times or 4 times.
That is the smarter way to do it. So how does a 2 become a 4? You square it. So that was for NO, because that's the one that was changing, correct? All right, now here's the same, and going down this time like 2x, correct? And what do I do here? 2x, that's just an exponent of 1. All right, so then I can solve for k. K equals the rate divided by NO squared and H2 to the first. We okay with that? Just Nisha knows what he said, so she'll answer it. All right, thank you, Nisha. Okay, when we plug this in, just the top row, so you plug in 0.136 on the top, you put 0.42 and you square it, and you put 0.122 and you don't square it, and all that equals what number? 6.3. Are we all right with that? Do you have it on your calculator still? Okay, don't listen to me. Don't use your phones as a calculator. I'm not yelling at Soraya. I'm saying everybody. Because your phone took this number and divided it by that number and then multiplied it by this number. And that's not how math works. And then you what? It's, I promise, you may not have done that then, but it's an order of operations problem. All right, 6.3 is K. So now I just plug everything in. My rate, 0.0339 equals 6.3 times, this is the one that's a 1. So 0.105 squared times x. Does that look about right? Okay, so I just take this stuff and divide it over there. And what do you end up with? 0.487?
Should it always be a multiple of the numbers before?
No, it doesn't have to be.
So your rate equals your 2 products. Oh. I don't know what I'm saying.
I don't.
You don't know what you
I don't either.
Yeah, so if you have 0.0329 equals, so you have to find 6.3.
Yeah, this is K.
So 6.3 is constant, and that is your rate.
This is my rate. This was NO. This was H2. Is that what it was? And NO was squared. H2 is to the first. Okay. Log into Canvas and go to the chapter 14 module. There's a quiz that says initial rate laws or something like that. Take that quiz if you would. There's an access code? What? This guy's on drugs.
I really hope you can't find it.
I realize it's like
It's not on your grade.
It isn't?
No, it's just to see if you got it or not.
I don't, in that case,
The code is hello, HELLO.
oh,
that's cute.
You're, no. So question, our overall average is 58, but really we would add 25 to that. So that's not bad. That's a 73. That's not great. I'm not wrong. So all but one of you got this correct. So when we look for NH3, then I know that thing's annoying right there. I apologize, but I was in a hurry, obviously. All right, so we would look where BF3 is held constant and something is changed for NH3. So when we went from here and up, we doubled and the rate doubled. So that would indicate that it was raised to the first power. The exponent that keeps the variable the same is a 1. Okay, next, BF3, we're now looking for where NH3 is held constant and where this is changed, and it is held constant in 3 different places. But the easier math, unless you like doing 3/4, would be, yeah, don't do that. Go here. Same, doubled going up, and I doubled and I doubled. So it is also a 1. All right. Then this one, just me being dumb, I guess, when I typed it. Most of you probably had, well, 3 people, maybe 4 tops, had it wrong. The rest of you had it right. It was supposed to be 3.3. What's that? Well, that's what happens when the teacher puts the wrong number in the key. Okay, but we knew that was a mistake because you can't get this right if that was wrong. So if a 6th trial is performed with concentrations of this and that, what would be the rate? So now that you knew K, you just plug it all in and you go. So there's questions like this on the exam. Make sure you are good at it. If you feel like you need more practice, you can do this very simple thing. Oh man, I thought I already did it. Maybe I didn't keep it open. Hey.
I actually really appreciated at 2 o'clock in the morning that spreadsheet.
What?
The night before the test, that spreadsheet.
Oh.
That was great. That's actually really cool.
You're welcome. So you're saying you would like me to do it again? Well, I'll pray about it. Okay. If you're like, man, I need more practice on this. I have no idea what I'm doing. Well, look at this. Determining rate laws from initial rates. There's multiple videos. There's my class videos. There's multiple. Usually anything from this purdue.edu I love. Let's see what it looks like. Sometimes it's over our head. It looks like it doesn't want to load. I swear it should. There you go. Hey, that's all right. Will you reach up and put the magnet in there? Okay. Well, it's not loading very well. But if you go to images, which probably won't load. Oh, there's the Purdue. Here's some tables. All right. Now, they do it a little bit different. You see this thing right here? This is the math way to do what I say to do without writing it down. So to me, I think it's pretty easy to look at the change and see what the other change is. This, you just plug everything in and it will give you a whole number usually.
where did they get the N and the N?
Those are the coefficients of a balanced chemical equation. All right, so determining rate loss from initial rates. If you go to images, you can see table after table. You can get as much practice as you want. Some are hard, some are easy. All right, so you could get endless amounts of practice. Now, they're not always that easy. Like sometimes you do the math and it's not a 1, 2, or a 3, and then life seems weird. But those exist. We just don't have to do them in this class. This one right here, where did it go? It's not always just 2 things in a reaction. It could be 4, could be 10. Then it gets super hard, but we don't do those in AP. We do sometimes 3. But anyway, you can get a lot of practice if you feel like it. Okay. I don't know, you want one more? You feel good about it? All right. We didn't do this one yet, so far away. Now, this, sometimes kids get confused on this one, which is silly. Don't get confused. Anyone know what confuses them? The rate is on the left. They're like, that is unacceptable. No, it doesn't matter where the rate is. It doesn't matter at all. Yes, Judah.
For the rate, you just choose any two, like rate 1, rate 2.
Say that again.
Can you just choose any two from the rates to get the rate loss?
The answer is yes, but if we're going to do it easy, it helps to pick the correct 2. Like there's some that are easy, some that are harder. Bennett.
Why does it stay the same when it's supposed to be?
Because life's not always easy.
Well, yeah, but like.
What do you do? No, you don't. You have to use your brain here. Yep. Okay, so we'll just stick with me. How about we do it together? This is held constant and this is doubled. Are we paying attention? That one's money. What happened here? Doubled. That one wasn't hard. So we would say y is to the first. Okay, and then you're offended because there's no time where this doesn't change, right? All right, so what I'm going to look at, oh, the switch colors here. Nope. I'm going to say this doubled and this doubled. What happened to this rate? Nope.
Oh, but there's a negative 4 in there too.
It's quintuple.
You,
Are you talking about a 10 and a negative 3?
yeah, between 1.4, so 0.0014, and went 0.0007. It just doubled.
So it's just trying to trick you, but if you know simple exponents.
It just doubled because this is a 7 and this is a 14. What?
The others are doubling the other way. So it's all just a 1 with an arrow turned right. Yeah, David, can you do the arrow backwards?
Okay, my fault. Okay, which arrow did I draw backwards? This one?
Yeah.
Okay, here we go. I apologize. Okay, now shh, think about it. It's not a 1. It's a 0. Murray, why is it a 0?
Because the X with the X doubling through.
All right. I'll do it if everyone else will be quiet. Y makes things double. We know that. Y doubled and X doubled, but the rate only doubled. So it means that the rate is independent of the concentration of X, or it's a 0. Because what happens when you raise something to the 0? It turns to a 1. So my rate law here would be rate equals K y to the first. Now, you can write x to the 0 if you feel like it, but that's just a 1. So it's up to you whether you want to write that or not. So there are things like a very, very, very simple equation. When we have magnesium solid plus hydrochloric acid, the rate of this reaction is not dependent on the concentration of a solid because there's no such thing. So if we did this study, if we doubled this concentration, that would affect the rate.
So how does it form something?
It reacts
With what?
with the acid. We're not saying the reaction doesn't happen. I'm just saying the concentration of the solid. We don't measure solids as a concentration because it's not an aqueous thing or a gas. So the reaction happens, but the rate is independent of this. It only depends on the concentration of HCl.
Because it'll go just as fast. If you put a little,
No. Well, okay, I got the answer to your question, probably the way you're asking it, you're right. But I don't want to write that sentence down because it's also kind of wrong.
So how come it's not just one since they all times by two?
because it's not double.
Because my change had no change. So, well, he's not alone in his confusion. I promise you're not alone.
So that's the problem. You're just looking at things when they're constants. That's what makes it easy. You can say, okay, the y doubles and then the rate doubles. So you'd say that's a 1.
Right?
And when they both double on both sides, yeah.
So here we go. Yeah, we changed y, which caused the double. We changed x also, but nothing changed.
Oh,
So if nothing changed, then it was 0. 5HCl, and I put 2 pieces of magnesium in, I will create more, but my actual rate will be the same. Okay,
so let's say
because I would have doubled it, but my rate I would have divided by 2 because I doubled at the same time.
So let's say you double both, and then the rate actually quadrupled.
Then they'd both be a 1. Because look, if I put a 2 here and a 2 here, what does that equal? A rate that's to the 4th. So that means the exponents would be 1.
So they both double.
Yep. But I had some number here that I didn't know. Well, actually, I did know it. I had a 2, I had a 2, and I got a 4. No, I got a 2. Then what must happen here? One of these cancels out, and the only way to do that is raise it to the 0 power. So now in this example, if I increase the amount of H plus, which is really what HCl is, then my rate does speed up. So this reaction, it is rate dependent on the concentration of acid, but not the concentration of the solid. I know it's kind of tricky, but really there is no such thing as a concentration of a solid. Yes.
Molecular level, how does that work? Because it's making more molecules.
It is, but we'd also have more moles. So our rate, it would cancel itself out. So it's not a perfect example. Right. Right. Okay. Now, so the rate law would be this. Rate equals K. I know it's written backwards, so you're like, what? You can't do that. All right, so then it would say find the rate constant. We would just plug it in. It'd be kind of nice because we wouldn't even need to worry about X. And then the units. All right, how do we find units? Okay, it's a piece of cake if it's only one thing to the first power. It's this unit. But it gets a lot harder. So when we end up doing this when we have like a 1, then we're multiplying these, so we end up with squares and stuff, and it gets a little more confusing when it's a 2 and a 1 and all that stuff. So we have under a minute left. So we'll talk the units tomorrow, but then we're going to learn another way to do this same process, but it's a completely different way. If you would like to practice this, there's one more picture there, or one more thing there you can take a picture of and practice at home if you feel like it.